But when it comes to Gen AI, I mean, we know that the output is always a natural language, an image, an audio, right? We have synthetic data sometimes, but most times is in that line. So for me, that's like a key distinction between them. So thank you very much for the contribution. I mean, that's a very good one. I think one of the things that we also um, pushed in for what's what I meant to use now um, in the resource that was shared also is that um, you know I think he spoke about the training of um, these genies, and I think he went somewhere towards talking about foundational model, right? So and can someone help me with when we say foundational model, right? When we say foundational model, what are we really talking about? Yes, please. Sorry, Fee. Can you help me with your name? I don't want to. I don't
Yeah,
want.
Fikoimi.
Okay, it's a very
You can
unique.
call me Adibola. Yeah, yeah.
Okay, all right.
Okay, so I think foundational models refer to models that are trained from scratch, like they are not fine-tuned. They are models that are trained from scratch, basically. So they are not built on top of previous models, right? Their weights, um, their parameters are created. They're not they are created from the initial training, right? And then they can be later fine-tuned for specific tasks.
Can we just can we clap for Adibola? Like, yeah, thank you very much, Williams. Yeah, that's a very good one. So yeah, they're basically like base models. Like, yes, in fact, there's nothing I want to add to it. Like, we have a large amount of data, we have vast quantity of data, and we then decide to, you know, retrain a model on, an AI model on this data, right? And the thing is, the exciting thing about these foundational models is that they can still be further adapted. That's, talking about fine tuning for various, should I use the word downstream task? Should I use the word downstream task? They can be further, so I mean, things like what maybe sentiment analysis, image captioning and things like that. So it makes sense. So you can, I can decide to pick a foundational model and say, okay, now this thing was maybe originally built for general text, but now let's begin to train it on, like someone said earlier about using LLM for law firm. I'm not sure if the person is here or in the, I can't remember who it was. Maybe the person is in Gen AI or the person is in ML business, but the person was talking about the idea of having is it law in Nigeria, being recouped and then being able to train a model on it and things like that. So, you know, it's because a foundational model already exists. If this person wants to start from scratch, okay, maybe cannot go into that one. Right. So yeah. So there's another topic that is very, very key. I mean, to be honest, I'm actually enjoying the people here. It seems like you guys are pros already. Like maybe you be teaching me self because I'm enjoying the conversation I'm getting from this group. Right. I think there's something else that was also mentioned that I really like us to talk about. Transformers, right? What are transformers and what makes them special when it comes to um Gen AI? Anybody? Yes, yes. Okay, I think. So Adebola, let's David go. You went earlier.
No,
Sorry.
no, I understand. Sorry, my hand I had not switched it off. So yes, David can go. That's my
Okay.
bad.
Okay, no problem. No problem. All right, David.
Okay, thank you. So transformers are like the latest type of machine learning model that is better suited for um, when it comes to context. So I think there was something in one of the reading resources they mentioned that transformers use what we call attention. So that is a way for it to basically refer back to previous texts. I'm using text as an example. So
Yeah.
better than that's why it's better than recurrent neural networks. I think yeah, that's what I read.
All right, thank you very much. So you mentioned something that I really like. That's the attention. Yeah. But there's something I'm also looking out for. Um, there's something I'm looking out for when it comes to what's the word I meant to say now? When it comes to transformer. I don't know. Does anybody else want to go for it? Yeah, Adibola.
Um, okay, so I think the major um innovation with transformer, like David said, is attention, but it is able to understand the context between sequences of uh values. Yes, I think not only like sequences of words is able to understand the relationship between them, and that's the major innovation from the other um neural networks, because the recurrent neural network was the I won't say the best, but before transformers was, I think, was the go-to model for most machine learning tasks most machine learning tasks that have to do with sequences of values or words. So the transformer major major innovation is the ability to understand the relationship between the sequences of values, and it also um it depends, but there are several types of transformers. So the encoder, there are some that are made with just the encoder, and there are some that are made with just the decoder, and there are some that are made with both. And for the encoder, it takes in sequences of values, and then able to capture the semantic relationship, that the meaning between those sequences of values, and then the decoder outputs sequences of values. Um, and then if you add both of them together, that means you can take in one sequence of values, and then you can output a different sequence of values, like maybe for translation tasks and so on and so forth. So that's all I have to add.
All right, thank you very much. So I think along the line you actually mentioned something that the main thing I was hoping to hear. I mean, the whole thing about this transformer, whatever is that we're talking about stems from their, should I use the word, the architectural system, right? I mean, I think when you talk about transformer, the first thing you want to say is that they are like, it's actually an encoder decoder system. They will now have different types under that, right? So you mentioned sequence, which is like, yes, very, very good, like very, very good. Now, I think there is, so let me use an example. What's this model again? Oh, I'm trying to remember this model that has short span of keeping words. Sorry, I just think it's the first thing that Google released, the first transformer model that Google released, 2018. Why did I just forget
Is
the
it
name?
BERT? Is it BERT?
Yes, Thanks you. Bless you. Yes, bet. Thank you. I don't know. I mean just disappeared. Now, what's the difference between a model like bet and let's say ChatGPT? Any idea? Okay. All right. GPT is decoder only. You're asking me, are you sure? Okay. All right. I won't say it. Yeah. Let me let somebody else say something before we go there. So yeah, you actually don't let me say it yet. BERT is encoder only and GPT is okay. Ah all right. I mean, okay, so BERT from the name, right? I think Adebola is okay. I can't imagine how encoder only. Okay. All right. I think there's a place where I can now do like big man now. All right. Well, don't mind me. So I mean, from Bet's name now, we know Bet is bidirectional encoder representation from transformers, right? And the idea of Bet is that it processes sentences at once. So it tries to look at both the words that come before and after a given word to understand its full context, right? But the thing is, as powerful as this thing is actually, do you know that it's actually not very good for generative AI in that sense? It's more discriminative in nature. Yes. That's why you see they use it for text classification, text analyzation, um, answering questions, doing named entity recognition, like you get. Um, Now, ChatGPT also does word processing text processing from left to right and the likes. But I think the key difference between them is that Brett is bidirectional. So it reads entire sentence at once. Meanwhile, ChatGPT is unidirectional. It goes from left to right, right? It goes from left to right. So Bert was actually made from, should I say, was made for, not from. It was primarily designed for understanding and interpreting language in a bidirectional manner, right? So what happens is, any place where the context from both the left and the right of the word is important, you use something like Bert. Now, I don't know if you've encountered something like this in maybe Gemini, maybe you did something on Gemini, maybe you're having a chat about, maybe you have a business idea, for instance, and you're chatting with Gemini. I think ChatGPT has gotten this better. I don't know what they are doing on this, but I think ChatGPT has gotten this better. But Gemini sometimes fails on this. And you, in that new chat, after maybe 2 days after having that discussion on business ideas and the like, and then 2 days later you didn't chat, you've even created new chat and done other things, maybe created new topics, whatever, but you now came back to that particular chat, that business idea chat, and then you now ask Gemini. I think they're also getting it now, Shabo, as at 3 6 months ago. If I've had experience with this, if you tell Gemini to revisit a part of the conversation, Gemini will not actually be able to revisit that part of the conversation because that part is gone, that context is lost, right? But ChatGPT, I don't know, those guys, they got this fast. I don't know how they did their training was very good, right? And so I think they call them in name. When is unidirectional, I think it's autoregressive. And the other one, I can't remember the other name, right? So they are different. I think training approach for birds from what I understand, they use what they call the mass language model approach. So they will they would mask, like cover some tokens in a sentence randomly, and then the model will begin to learn to predict those missing words based on the surrounding context, right? So it tries to read the whole sentence and now feel like, okay, maybe I'm saying Ade is going to school. That's a full sentence, but and I said Ade is dash to school. So it tries to read Ade is and then to school. So you now try to say, okay, what makes this sentence complete? What makes it make sense? Then it predicts any other verb or whatever that it thinks should um go in. But the likes of ChatGPT, they use what we call casual language model approach, right? It just generates text by predicting the next word based on previous words in a sequence, which takes me back to that encoding, decoding that you mentioned earlier. So you can see that what is happening there is what's the word I meant to use now? What is happening there is this um um chat GPT, right? Let me see. um I don't know what parameter I should give them that they are doing with this encoding decoding system, but this same encoder decoder attention that they are doing, right? I think there is a, is it mathematical science or that is that, they used to create a layer. So it takes some what we call query vectors from the layer below it. Then it now looks for the key, the value, directly from the output, when we start going into the stack of the encoder and the decoder. So what happens is, based on this, the decoder can focus on the appropriate part of the input sequence during generation. So, but I'm already sounding too deep, deep, deep. Don't let us go there. Let's go back to the the intro that I was talking about, so that I will not veer off, because it seems like my head wants to start going somewhere else now. Let's talk about hallucinations, right? Because this is something that is common with Gen AI. I'm sure some of us might have experienced this, probably with ChatGPT, or I mean, how many of us have experienced something like that before? Like you're asking ChatGPT something and he's giving you an answer, but with confidence. But you in your heart of hearts knows that ChatGPT, you want to throw me inside gutter. Like, hello, I'm asking you, I'm not that dumb now. I know this thing, but oh boy, what you will like baby day? Like, where are you taking me to? Right. So hallucination is something that is very common, like with these Gen AI guys, like they just and it's not their fault, right? It's not their fault. It depends on the training data, and based on that, they have, some data were not really, some people can train AI on data that was not really cleaned. Like, let me use the word noisy, a data that is very noisy, right? And when you are talking about, let's see, for instance, you are talking about diagnosis, health diagnosis, and inside that health diagnosis, you forgot to remove some, maybe financial analytics data or something. And every time, maybe according to the AI, every time he sees diabetes, he sees somebody that is buying like 20 liters of Coke. It makes sense in a way. You say, because this person is drinking Coke, but the person is just buying. This same person was drinking, right? And then it tells you that because you are buying 20 liters of Coke, you have diabetes. Alpha, no, it might be for business. Do you get? But that's because they didn't really clean that data properly. Do you get? So hallucination is like a potential issue that transformers have. Like, they can generate things that don't exist. I think at the beginning, this thing, although this one is not, I wouldn't say it's a hallucination in a way, because, but it's not hallucination because this one is bias, in the sense when you're asking for ChatGPT to generate an African man or some African medical doctor in the US or something, and the person is still a white man, or at the end of the day, when you force it too much, it generates a baboon, right? So obviously, I don't know, the data it was trained on does not recognize a black man that is a medical doctor in the US. So he's picking the like closest thing. So I mean, hallucination can be a reason of so many things, right? But I mean, it's something that happens with something that happens with Gen AI a lot of time, right? A lot of times. So um before I say something else, I mean, I think basically we understand how transformer works. So that which is like the major of large language models like LLMs, and LLM is like the whole thing about Gen AI, right? So um I think we'll get we're going to be moving forward from here. But let's go to talking about some of the environment, some of the things that we use to train transformers, right? How many of us use like PyTorch or TensorFlow? Yeah, I've used it before. Okay. Okay. Let's start with. Okay, is that a question or you're just signifying? All right. Okay. Okay. How
I'll
many of
just
us,
signify.
if you have not used it before, can you drop it in the chat? Like, I've not used any of these two before. Okay, every one of us here have used it before. Okay, so me, I want to ask a question. If everybody here have used PyTorch and TensorFlow before, what are you doing here? You don't mind doing? All right. I mean, it's like I'm talking to professors here. Oh. Let me know what I'm going to be saying. Oh. Okay, right. Um, so I'm just going to. I don't know if before I say some final stuff, because does anybody have a question as regards the? I know some people might even have gone to week 3 and week 4, even finished by now, safe, but we are going according to what we have here. So if you have finished it, please don't rush us, pardon us. Um, but is anyone with any question as regarding the resources for the 2 weeks? Any question, any suggestion as to what we could do better? Um, Maybe some of the resources, we have access to more resources that I think should be involved, should be included in the resources for others to learn or something. Anyone among us, please feel free to unmute and just contribute. Okay, no questions. I said it. I have transformers here. I have I say transformers. I have professors here. So so Uh, all right. So this is not. I'm not sure we spoke about anything related to this in that. I'm not sure it's in the resource that we shared for the 2 weeks. But I want to ask this. I mean, it's just. I mean, I believe majority of us already have an idea of this thing. So, can we talk about in the next? We should be running up soon. Like, okay, 2 minutes time, but we'll borrow 3 more minutes to make it 5 minutes time, right? Can we talk about RAG? I mean, because I think is one of the things that is, in vogue right now. Like many people are doing that a lot. Companies are doing that a lot. I mean, how many of us have like had experience with it before, or like played around with it before, or this Adebola man, seems I'm going to come to your class. So. All right, please go ahead if you have anything to say. Let's talk about it. Like, what are what are the we're just discussing about RAG. Like we are now in the world of AI everywhere. Every company wants to be involved in AI, and some of them how they are doing that is through RAG. Some are going through the agentic route, right? But let's just talk about RAG. I mean, we are done. We are just doing a recap of our resources. So when we get into deeper one, maybe for the next session. I'm sure we'll have thicker things to talk about, but right now it's just an introduction, right? So but let's just say something about RAG, pros, cons, what's our view about it and the likes. So Adibola.
Yeah. Okay. So RAG is in in full, RAG is a retrieval augmented generation. So that's basically you have like a model, an LLM model, and you want to give it context. Um, you want to give it context from another source, right? So the let's say you have a document um or maybe some particular on a particular field, right? That the model might not be easily able to answer your questions on, or it was not really trained on it really well. So you can then provide that context. And also, if you have like I think they call it proprietary data, like your own, maybe a company's personal data, like uh maybe the rules, maybe a company has some personal data, right? Proprietary data, sorry, and to they want the model to be able to give it answers based on that data. So basically, RAG allows you to provide to match your data with the model. It allows you to provide more context to the model. And the pros is there are already a lot of pros because um the you don't have to like fine tune, right? So most times, because fine tuning takes can also be computationally expensive, right? And so you might want to fine tune the models so that the model can be more okay, can be more suitable for your task, but it can also be expensive to do so and might also be time consuming. So by using RAG, you can actually bypass um that particular process and allow the model to actually understand what you want it to do for you. And then also that's for the pros. And then for the cons is some models might not have enough window, like context window, for you to fit in all the data that you want it to use. So for example, a model might not have, let's say you have a PDF of maybe 50 pages on companies rules and regulations, and maybe the model will not, it depends on the model you're using. Maybe we are using like all these top end models from companies like OpenAI, um or maybe Gemini. They will be able to the model will be able to fit in a lot of the context into its window. But if you are using like smaller models, they might not be able to fit in everything, and because of that they might start to hallucinate, or it might even like they might start to hallucinate because
Yeah.
the context window is too full. So um that's just basically the story about rack.
Thank you very much. Thank you very much, Adibola. That's very, very extensive.
Okay.
Okay, let's have Williams also. Then David will go after. Williams, over to you. Oh, okay. I saw you were raising your hand. All right. David, over to you. I think.
Sorry. I was raising my hand. I'm sorry.
Oh, I saw that you went off again. Sorry.
Yeah,
All
I
right.
thought
Yeah,
I didn't.
yeah, you have the floor.
All right. So, like you said, RAG is simply just retrieval augmented generation. So basically, RAG is just like retrieval and generation. Why the augmented? The way I understand it, anyways, it's just like combining both of it together. So retrieval is more like taking information from a place or whatever it is, maybe your database or your text of data, PDFs, whatever, whatever. So the way retrieval works is just like breaking them down. Although that's some other parts in that you use with RAG, but it's you use vector similarity. to break down all your words. So you use RAG to get some information, put them into a particular groups, where you group your whole database into how many groups you want, and then you use vector similarity to generate to get more information depending on what the user or the person using it at that moment wants. So why the generation part just kind of like converts whatever it's retrieved using maybe a transformer in the back end or whatever to generate information to you. So retriever augments and generation to give you more information. And like you said, it avoids hallucination. That's especially if you use only RAG. Okay, so there's almost no issue of hallucination where you're using basically RAGs. And whatever. I think that the thing about RAG is that it's always very contextual. It always sticks to whatever database, whatever information, whatever PDF you give. It doesn't go
Mm.
outside of it. Okay, so that's what I just have to say, anyways.
All right. Thank you very much for that. That's let's have David. And David, you have the floor.
Okay, yeah. Okay, so it's not as if I'm adding anything to what they said. I think they've basically covered it. They've explained what RAG is, how it works under the hood. But I want to say some of the cons because um I was I was working with I was working on a project and it involved getting like documents, feeding documents and organizing them, blah blah blah. But all in all, we used a RAG based approach, and I can say that from that experience, the cons of RAG are that firstly, it's it makes the it makes output slower, like a lot slower. Although that can be mitigated if we have like standard GPUs and all that. But yeah, it makes output slower, and also it depends on how I don't say structured. Um it depends on how relevant the data is to the query. So if there is no if we have a bunch of maybe we have websites, documents, and all that about cooking, and then we are asking it something related to business strategies, it is still tend to hallucinate. And and if care is not taken, we would some people would take it as at face value that okay, since we know that this model is getting its information from somewhere, it has to be true. Meanwhile, in some cases, might still be hallucinating. So I know that, although I've not really done much research of what's actually going on inside, but I know that different, like the commercial LLM, Gemini, for example, whenever you are referencing a document, it has a way to link to where exactly it found that information. So again, I'm not sure how that works, but but yeah, I think the time taken. Okay, firstly, the pre-processing of data, um they divide the things into chunks and then do vector embeddings and all of that. That part that part takes time, and then actually using it in the model also takes its own time. So yeah, that's just all. Those are the cons that I was able to notice. But apart from that, I think the pros outweigh the cons a lot.
Yeah. Thank you guys. Thank you so much. And I like the fact that you spoke about this, the last thing you spoke about, the ingestion. I mean, RAG basically has four components. Yeah. Ingestion, retrieval, augmentation, and then generation. Yeah. And in ingestion, that's where we have the, having those chunks of data, dividing into smaller pieces, probably based on user queries, based on data, based on the use cases, whatever, and then having it converted into vector embeddings, which are then loaded into a vector database. I think most times this ingestion usually happens offline though. But I mean, some still do it. I mean, most people that have all their stuff on the cloud still, I mean, it might be offline, online, right? In a containerized, um, environment. But yeah, after that, then you begin to retrieve relevant data based on a particular user query or something, and you just search it against the DB after you convert that user query to a vector embedding also, right? So basically, it's an interesting concept, and it has actually changed how AI. What's the word I'm going to use now? Um, the AI output, the AI delivery for majority of the companies, and it makes sense that it exists. But we'll get to that later on. I think we have actually taken a while. This is 12:11. I've taken 11 more minutes, so I think we should round up here. I'm not sure if there's any other question or any other thing, but um, I'm actually happy that majority of us here we are senior men, senior people in AI. So it means that majority of our work will not be hard. Majority of our work will not be hard. We'll just we're going to go straight forward to what we're going to do. But I hope we're trying to play around with some of the assignments. um the week 1 and week 2 we didn't really focus on it because if you look at it, it's just basically setting up of environment and probably just playing around with the transformer to install it and the likes. But we're going to be doing some major assignments later on, and we might actually add one or two things. I might add one or two things. I mean, I'm seeing that I have people that are capable here, so I might add one or two things. So, but don't worry, it's just going to be something small. Yeah, I think that'll be all for today. We'll keep sending out emails and then information on the group as required for us along the line. But we'll be going to our week 3 and week 4 now to study the resources. And I mean, I believe that we all can keep sharing our knowledge, and it helps us get better also. So even on the group, please feel free to drop whatever you find or you think is better, and then we would see how far we go together as a group. Thank you guys for joining this today. I'm really, really happy to have you guys here, and I hope we enjoyed ourselves. All right, please do take care of yourself and enjoy the rest of your weekend as we launch into a new week. And by the way, happy new month to us all. All right, thank you very much. Thank you very much. Would convey again for our next session soon.